It's 3 a.m. Your pager duty goes off. Your pod just restarted and the production is sealed. Nothing can talk to your database. Your apps are timing out. And now you have to drag yourself out of bed. Find the unsealed keys and manually type them in just to save production. Stop doing this. In this video, I'm going to show you how to turn on Vault to set and forget service on Kubernetes using Google Cloud KMS. We are going to build a self-healing cluster where if a pod dies, it comes back quickly. It comes back fully unsealed automatically. No keys, no manual steps, and most importantly, no 3 a.m.'s wake up calls. Let's build it. You can see on my screen here, this is the official documentation of Vault and Auto-Unseal. There are multiple ways you can choose what fits for you. You can use Hashicorp Vault, Google KMS, or AWS. You can even use another Vault and use Transit Secret Engine to do it. So in this demo, we will be using Google Cloud KMS. So first, I have created the Terraform code, the basic simple setup. So in the backend file, I have given my backend, and in the main file, I import the existing keyring and the crypto key. This is because when you run once the creation of a KMS key, if you run with the same name, you will get some error. So I want to import if the name existed, and this is how you create. First, you create the keyring, and then from the keyring, you create the crypto key. And here you need to specify the purpose of the key, and we are using encrypt and decrypt for Vault. Why I'm creating the service account and giving permission to that service account is because when Vault runs on Kubernetes, it needs to connect to Google Cloud, have access to KMS key, and it can use it as encryption and decryption. So we create a service account, and then we will later create Kubernetes secret for Vault to be able to connect to the crypto key. So let's commit this, and later on, the next steps, we will create the configuration for Vault. Before committing, I have prepared a Terraform GitHub action to be able to run the setup. So let's apply it. We can run our GitHub action. Okay. The job is completed. So you can see here, and we can use it. So we have applied our Terraform to create the keys that will help us to unseal Vault. To install Vault, we use Helm chart as we did for manual unsealing. What is important is the configuration is seal block, and here we are using GCPC KMS, which is the KMS key on Google Cloud. So this block differ from the keys that if you choose AWS or Azure Key Vault, you will have different configuration. But for Google Cloud, you need to specify the project, the region, the keyring, the crypto key, and the credential. And these credentials should have at minimum the encrypt and decrypt so that your Vault can use them. And then the credentials should be mounted as secret. So you use extra volumes and you specify the secret. This name should match with the name here on this. So this is the name of the secret, and this is the key in your secret, mean the KMS keyring. So you need to create connection credentials. So you create a service account credential by running Google Cloud AIM service account key. This is the file, the JSON credential that it will create, and so you get the service when you apply the Terraform. This is the step that we have already done. So to create the secret, you run kubectl create in the Vault namespace, and you specify the name of the secret, which we have already set in the values here. This is the one, and you apply it. This key is the one that will be filled at the end of file. Here you see the file name is sa.json, and I use Ansible to do that. So you see that the secret has been created, and this is the SE that will be applied as the file name. So let's apply the changes and see Vault being deployed. We will create request set merge it. I'm running Ansible to apply the Argo CD setup. I'm creating apps of apps. So you can see that the Vault containers are creating. Now the Vault is running. We can initialize it. With Auto-Unseal, we will only have to init, and then Vault will unseal itself. We need to run Vault operator init. And you see that it was successful. We have a recovery keys, one recovery key, because we have specified here that we want one recovery share keys and one threshold, and we have received a root token. So be aware that when we use auto-unseal method, we use recovery keys instead of key shares. The recovery keys do not unseal Vault. It's Vault that automatically unseals using KMS. The recovery keys are used only for generating a new root token, also for performing recovery operations or rekeying the recovery keys. So now you see that after we have init Vault, the first server of the cluster is unsealed. We haven't done any operation of unsealing. The next one, we need to join to the cluster. So if we run Vault operator Raft join, the first one, it's joined. We do the same thing for the second one, and it's joined. If we check, we can see that Vault is healthy. All the 3 nodes are running and ready. We can use them. We don't have any ingress, but we have gateway with Cilium. For now, it's not programmed because to run the Minikube tunnel, you see that we have got an IP address for Vault. I will set etc host. Now connect to Vault. So if I grab the token, we have our fresh instance of Vault. Delete. And even delete to port. See? You see that the port that I have just deleted, I haven't done anything, and you see port has healed themselves. And there you have it. You have gone from a fragile manual to a full automated production hardened Vault cluster. By using Google KMS, we have removed the human element from the recovery process. So next time a node crashes or a pod restarts in the middle of the night, Vault will unseal itself. Your apps will reconnect, and most importantly, you stay at sleep. In the next demo, we will explore Vault dynamic secret with Postgres. So thank you for watching, and see you in the next demo.